Hello everyone. This video covers the solutions to study guide for test number 2. Number 1 is asking you to find the derivative. The derivative involves exponential functions and logarithmic functions. So before we do the derivative, recall the following. The derivative with respect to x of e to the u, where u is a function of x, is equals to e to the u times u prime, and the derivative with respect to x of L in u, where remember u is a function that depends on x, that this is equals to the u over u, or you can also say u prime over u. Now, number 1, part A, this part is a product, so you have to use the product rule. This one is not a product. This one you just have to use this rule. But for the first part, you have to use the product rule. So according to the product rule, h prime is going to be the derivative of the first one times the second one plus the derivative of the second one times the first one, and then plus the derivative of the last term. Right? The derivative of e to the 4x using this property, okay, using this, is going to be e to the 4x times 4, then times x cubed. The derivative of x cubed is 3x squared times e to the 4x, and then the derivative of ln using this formula. Here u is 3x plus 2. This is going to be the derivative of u. So if u is equals to 3x squared, the u is just going to be 3, the x, or just 3. So therefore this will be 3 divided by u, which is 3x squared plus 2. And then you can simplify a little bit more, but this is pretty much the answer. You can factor the e to the 4x and also the x squared. So this will be 4x plus 3, and then plus 3 over 3x plus 2, and that will be the answer. In number 1b, you have to use the quotient rule. So remember, h prime is going to be the derivative of the top times the bottom minus the derivative of the bottom times the top, okay, divided by the bottom square. Before we take the derivatives, notice the following. The ln of x to the 4 by the properties of logs, that is equals to 4 ln x. So this will make taking the derivative easier, because you take the derivative of this is the same thing as the derivative of this, which will be just 4 times 1 over x. So you don't have to do it this way, but that just makes this easier. So then if that's the case, then from here we have the h prime is going to be equals to 4 over x times e to the x minus the derivative of e to the x is just e to the x times 4 ln x, and all of this is divided by e to the 2x. And this is okay, there's no need to simplify this more. In number 2, we need to use implicit differentiation to find the derivative. The right side is actually pretty simple to do, so let's do that first. The derivative of 3x is just 3 if the derivative of y, remember, is just y prime. Okay. The one that is a little bit tricky is this, e to the xy. So the derivative of e to the xy is equals to e to the xy times the derivative of xy. And notice that this is a product, so you have to use the product rule. So this will be e to the xy, and then when you apply the product rule here, this is going to be 1 times y plus y prime times x. And then if we distribute this, this will be y e to the xy plus y prime x e to the xy. Okay. So that's what we have on the left side. So this will be x e to the xy plus y prime x e to the xy. Now remember that you're trying to solve for y prime. So you have a y prime here and a y prime there. So you combine the y prime. So this will be y prime times x e to the xy. You need to move this to this side. So it's going to be negative. So it will be minus 1. And then on the right side you have the 3, and then you need to move this to the right side, so it will be minus xy e to the xy. And then to solve for y prime, just divide both sides by this part. So therefore y prime will be 3 minus xy e to the xy divided by x e to the xy minus 1. And this is the answer. All right, before we take the derivative of 2b, it's easier if you do it this way. You don't have to do it this way. It will make it easier. ln of xy is equals to ln x plus ln y by properties of logs. So therefore, if you apply the derivative, well, the derivative of ln x is 1 over x. The derivative of ln y is y prime over y. And the derivative of x cubed is 3x squared. Since you want to find y prime, you need to leave it by itself. There are many ways you can do that from here. You can multiply everything by the LCD, which is xy. If you do that, you'll have y plus y prime is equals to 3yx cubed. And therefore, y prime is going to be 3yx cubed minus y. Actually, I forgot there is the x that goes in here. So you have the x here. So you have to divide the whole thing by x. So then the answer will be y prime is equals to 3y x cubed minus y divided by x. Okay. All right, so now let's move to antiderivatives. Remember that we have 3 basic rules. U to the n du is u to the m plus 1 over m plus 1 plus c. So all you need for this formula is to identify what's the value for n, which it could be a decimal or a fraction or a whole number or a negative number. Then e to the u du is e to the u plus c. And then the last one is that du over u is equals to ln u plus c. So this example for this one, and this one, we're going to use the first formula. And for this one, we're going to use this formula. So I'm going to do one by one. So the integral of the first one is going to be 7x to the 4 over 4. because for this one the value for n is 3, so 3 plus 1 is 4 over 4. And then for this one it's going to be 2 x to the negative 5 plus 1 over negative 5 plus 1. Then the integral e to the 2x, the special case of this when u is just equals to kx, this is 1 over k e to the kx, so this will be 1/2 e to the 2x. And then for the last one, remember that the square root of x is the same thing as x to the 1/2, so this will be plus x to the 1/2 plus 1 over 1/2 plus 1. So then you simplify. The first one is already simplified, so this is 7/4 x to the 4. The next one is going to be plus 2 x to the negative 4 over negative 4, so you can simplify this more. This one is done. And here 1/2 plus 1 is 3/2, and the reciprocal of 3/2 is 2/3. And don't forget the plus c. And that's it. This one you can simplify to negative 1/2, but this is enough. You leave it like this on the test. Alright, so remember we're only using technically these 3 rules for the problems we're doing. And in the next 2, I think we use these 2 only. Alright, for this one, we're going to pick u to be ln x. So this is the substitution method. So the u, it will be the x over x. So notice that you can rewrite this as u q, because u is ln x, so ln x q will be eq. And also notice, and this is very important, that the u contains the dx and the x. So therefore, this is exactly just the u. Now by formula number 1, this should be u to the 4 over 4 plus c. But then u was equals to ln x. So this is ln x to the 4 power over 4 plus c. And that's it. For part c, this should be part c. Notice that if you pick u to be xq minus 2x, the derivative is 3x squared minus 2 dx, which is exactly what you have on the top. So therefore, this is just the u over u, which is the integral number 3. And this is ln u plus c by u was equals to xq minus 2x plus c, and that's it. All right, let's move on to number 4. Part A is just algebra, has nothing to do with calculus. The domains, and this is a polynomial, is all the real numbers, so it's from minus infinity to infinity. And the y-intercept is, remember, y-intercept just means x equals to 0. So if x equals to 0, this will be 0, this will be 0, this will be 0. So the only thing left is 2. So this will be the point 0, 2. Okay. Then it says find the intervals where the function is increasing and decreasing. So for that, we need the derivative. F prime will be 3x squared minus x minus 6. We need to find the critical points, and to do that you need f prime equals to 0. In this case you can factor this, so you have to use the quadratic formula. The question you have on the test, you should be able to factor it. So you use the quadratic formula. This is equals to 1 plus or minus the square root of 73 divided by 6, which gives you 2 critical points. The 2 critical points are x equals to 1.59, and the other one is x equals to minus 1.26. Like I say, you don't have to worry about decimals on the exam. They should be whole numbers. So 0 is here for reference. The first critical point is here, 1.59. And the other critical point is here, minus 1.26. So now you just need to check here, here, and here to see if it's increasing or decreasing. If you pick 0, notice that this will be 0, this will be 0, so this will be negative. So that means that between these two values, this is decreasing. Remember, at this point, this is flat. This is flat because it's a critical point. Notice that if you pick, I don't know, let's say 10, and you should check this. If you plug it in here, this will be positive. This will be minus 10, but the 3 squared is 300, so the whole thing will be positive. So it's increasing, and you can check that here is also increasing. Okay, so therefore, what is this increasing? This is increasing from minus infinity to minus 1.26, or for 1.59 to infinity, and this is decreasing just from minus 1.26 to 1.59. Or essentially this is the part what is increasing, this is the part what is decreasing, and this is the part what is flat, or the critical points. Now from here you can see it's obvious that this is the maximum and this is the minimum. So what is the relative maximum? It will be f of minus 1.26, whatever that is. So this is the maximum. And the minimum, it will be f of 1.59, okay? Which I believe this is 6.77, and this is minus 4.78. Now the points of inflation, that happens where the second derivative is equals to 0. The second derivative will be 6x minus 1. So therefore, the second derivative equals to 0 implies that 6x minus 1 is 0, which means that x is equals to 1, 6. So this is the inflation point. Right, so this is the inflation point. We just need to check where this is concave up and concave down. So we plug any value here, let's say 1. I mean, if you pick 1 and you plug it in here, you can see this will be positive. So positive means concave up, which means this. And if you pick 0 and you plug it in here, you can see this will give you a negative value. So that means it's concave down. Therefore, this implies that this is concave up from 1, 6 to infinity, and concave down from minus infinity to 1, 6. All right, so now let's move on to the optimization problems. So let's start here with what we are given. We're given the volume, and you want to maximize or minimize the expenses or the surface area. So remember that the volume is equals to pi r squared h, and the surface area is equals to 2 pi rh, which is the side of the cylinder, plus 2 pi r squared, which is the top and the bottom of the cylinder. So essentially what you're trying to minimize is the surface area, which is this formula. But the question is set up in terms of the cost, and it's telling you the top and the bottom are 2.5 times more expensive than the side. So therefore from here we're going to get a cost function, which is going to be 2 pi rh plus 2.5 times 2 pi r squared, which is, this is the top and the bottom. Now here you have two variables, the radius and the height, and remember you can only solve this with one variable. From here, notice that the volume is constant, pi is constant, so you solve for h, and if we solve for h, this will be equals to the volume. Okay, so we solve for h. H is going to be the volume divided by pi r squared. So if you enter that in here, this will be 2 pi r times v over pi r squared. And then this will be 5 pi r squared. Before we take the derivative, notice that you can simplify this more. This will cancel 1r and the pi's will cancel, so this will be 2b over r plus 5 pi r squared. Notice that this, the b over r, is the same thing as b r to the -1, which is easier notation when we take the derivative. Right, so therefore from here, the derivative of the cos is going to be minus 2br to the -2 plus 10 pi r. Now we need to find the critical points, and for that we factor, and remember you should always factor the smallest exponent. So in this case we're going to factor minus 2r to the -2. If we multiply times b, it will give us the first term, and then it will be minus, to give you the minus and minus is positive, it should be 5 pi, and then this will be r cubed. Why? Because r to the -2 times r cubed will give you r, minus 5 times -2 will give you 10, and then you have the pi from there. Since r cannot be 0, because it will give you a undefined value here, but in either case it cannot be 0, because then this will not give you a cylinder. If the radius is 0, then this will not exist. So that implies that the only critical point is when b minus 5 pi r cubed is equals to 0, which means that r cubed, you do the algebra, it will be b over 5 pi, or r is equals to the cube root of b over 5 pi. The question is asking you to find the dimensions. Okay, so therefore this is the first dimension. You just need to figure out now the height, but the height is equals to the volume divided by pi and then r squared, but r is this, and I know this looks a bit messy, you can simplify this more, but this will be enough. Now, just to make sure that this is actually a maximum, remember we use the second derivative test, using the second derivative test. According to the second derivative test, if the second derivative is positive, it's the minimum. Well, what is the second derivative? The second derivative will give you 4 pi br to the -3 plus 10 pi, and you can check if this is always positive, so that means this is an absolute minimum. Now part B is very similar to part A. The main difference is that this is a box, not a cylinder, but it is asking you essentially the same thing. Now the volume for a box, remember, is equals to length times width times height. And the surface area, since it has 6 sides, the surface area is equals to 2LW plus 2LH plus 2HW. Again, these are the default formulas. You have to modify them based on what the problem is telling you. It's telling you that the volume is 300 inches cubed and that the length is twice the width. So therefore, from here you have a 300 is equals to 2W times W times H. Or that means that 300 is equals to 2W squared H, or that H is equals to 300 divided by 2W squared, or equals to 150 over W squared. Also from here, the surface area is going to be 2 times 2W times W plus 2W times H, but now H is 150 over W squared, and then 2H, which is 2 times 150 over W squared times W. So we simplify this will be 4W squared plus 4 times 150, which is 600W over W squared plus 300 over W squared times W. Notice that you can cancel this in here. So therefore this is 4W squared plus 900 over W. Just like in the previous problem, we need to find the derivative to find the critical points. So S prime is equals to AW minus 900 over W squared, or you can say AW minus 900W to the negative 2 is equals to 0. Now you can factor 2W to the negative 2. This will be 4WQ. It's very similar factoring to the previous problem. Minus 450 equals to 0. Therefore, that means 4WQ equals to 450, or WQ is equals to the Q rule of 450 over 4. I mean, W will be equals to that, whatever that is. And to find the other dimensions, remember, once you know this, remember that the length is equals to 2W and the height is equals to 300 divided by 2W squared. So you just play it in here and in here, and that's it.